Hello Gators, this is 6-5 Properties of Special Parallelograms. I can use the properties of rhombus, rectangle, and squares to solve problems. Day 1. Let's take a look at this rhombus and let's take a look at some of the special things that a rhombus has that not all parallelograms have. Now, we know that a rhombus has 4 congruent sides, and because it has 4 congruent sides and it has this shared side right here, we know that this triangle can fold onto the other. So this triangle on this side will be congruent to this. So we know that this angle right here will be the same size as this angle. When you fold it over, they'll fold over and that'll match. So measure of angle 1 plus measure of angle 2 is going to equal 180. But remember, measure of angle 1 and angle 2 are exactly equal to each other. So we could just substitute measure of angle 2 and write measure of angle 1 because they're the same. And then we'll have 2 measure of angle 1 equals 180. And therefore measure of angle 1 equals 90. And if you think about it, that's the only way two things add up to 180, and both of them have to be the same, that those angles have to be 90. So these diagonals are making a right angle. Let's also now take a look at the folding process. When we fold this triangle on top of this, we're going to find that this angle and this angle are congruent, and this angle and this angle are congruent. So they're being cut in half and they're both the same. Now remember, this is a parallelogram, so they all end up at, actually opposite angles are congruent, so they all end up being the same size. So angle 1 is equal to angle 2, which is equal to angle 3, which is also equal to angle 4. Okay, the opposite angles are congruent and the other little halves are congruent. Okay, and that's what the theorem says here. If a parallelogram is a rhombus, it has to be a rhombus, then the diagonals are perpendicular bisectors. Now they have to bisect each other because parallelograms do that. Parallelograms, the diagonals are bisecting each other, and now we notice that this is also a right angle. Let's take a look at these diagonals. Remember, these can fold onto each other, so this angle and this angle are equal, and angle 3 and angle 4 are also equal. All of these two are equal, and they're also equal to 3 and 4. All 4 of these are ending up being equal, and that's the same with all of these. These angles here are going to be equal to each other, and they will be equal to these other angles over here. So all 4 of those angles are equal as well. So let's take a look at this picture and see if we can figure some things out. They want us to figure out how big this is. So if this is 3, I know this is 3 up here, because remember, diagonals bisect each other. This is a parallelogram. And this is obviously a rhombus, so I know this is a right angle. So let me see if I can't try to figure out what this length is. This length right here is the side of this right triangle. A squared plus b squared equals c squared. And we have one of our sides, 3 squared. We don't know what that other side is, this other leg, but we know the hypotenuse is 5 squared. So this is 9 plus b squared is equal to 25. B squared is equal to 16. So b is equal to 4. Now this being 4, I know the other side was going to be 4. So now I can answer the question. The answer is 8. Now let's talk about figuring out how big RPS is. We want to figure out this angle right here. So we know that this is 70, so we know this other side is 70 because opposite angles are congruent. And here we have an isosceles triangle, and we know in an isosceles triangle these two angles are equal. So I'm going to take 180, subtract 70, and that's 110. And I know I'm going to split these up equally, so that will be 55 and 55. So the answer is 55. So I'm using the ideas that I know about a rhombus. Now let's take a look at a rectangle. Now a rectangle has 4 right angles, and we know that since it's a parallelogram, opposite sides are congruent. I'm going to take this triangle and this triangle. They're overlapping triangles, and I notice these two triangles are congruent by side angle side. And when they're congruent by side angle side, I can say AC is congruent to BD by corresponding parts of congruent triangles are congruent. So now whenever I see a rectangle, I know the diagonals are congruent. Not only are the diagonals congruent, remember the diagonals also bisect each other. So all these little pieces are going to be all the same. All right, so let's take a look at this. This is a rectangle. We want to find each angle if angle 1 is 50. So this is 50. I know this is a right angle, so this will have to be 40. Now this is the alternate interior angle, so that's 40. And let's see, remember this is an isosceles triangle. All of these parts are the same, so this is going to be 50. That's 100. 100, that'll be 80. And across here, the vertical angle is 80. This will be 100. This is an isosceles triangle, so this is 40. This will be 40. This is again isosceles triangle. This is 40. And this is going to be 50 right here. And so that's how we figure out all the angles. Okay, PS is actually a diagonal. So they're telling us this diagonal is this. And then they're telling us this diagonal right here. And that's this. And now, remember we just talked about that diagonals are congruent. So I'm going to set this diagonal 6 plus 3 equal to this diagonal 7x minus 2. Subtract 6x on both sides. So that'll be x minus 2. So x is equal to 5. And that's what we were supposed to find, is find what x is. Okay, and now remember this is a rectangle and all the diagonals are congruent and they bisect each other. So each half is going to be the same. So I can say this half and this half are the same. I really could have done this problem if it had been a parallelogram, because parallelograms, the diagonals bisect each other. We're going to add 4 to both sides, and then we're going to divide by 2, and that is 20. And so x will be equal to 20. Now this is our summary so far. In a rectangle, we know that the diagonals are congruent and they also bisect each other. So think about this picture. If a parallelogram is a rhombus, we know that the diagonals are perpendicular and the diagonals are also bisecting these angles. So these angles are all cut in half, cut in half, cut in half.